Thank you all. I've been told I can't move around too much because of the recording, and that's going to make me a bit fidgety because I like to point at things while I talk. So I apologize right now if I move away from the mic. Just kind of herd me back towards this way. Oh, it would help if I turn this on. Cool. As said, I'm Marcus Noble. I'm a platform engineer at Giant Swarm. These days I work on release engineering, CI/CD, tooling, infrastructure, things like that, as well as some like general provider agnostic Kubernetes development. I also have relatively recently started a newsletter called cloudnative.now, where I do a roundup of all the month's cloud native stuff that's been happening in the community. It's a good way I've found to kind of keep up to date with things. And as of now, I've got about 7 years worth of experience working with Kubernetes. Over that time, I've had a lot of different roles. So I started off my journey with Kubernetes as a full stack Node.js developer, where I was tasked with figuring out what this new Kubernetes thing was and whether it was useful for our e-commerce team. Turned out it was. Ended up running 3 clusters for this small team. Moved into a role within the same multinational organization where I was doing like tooling and best practices for the other teams within the organization to make use of, and then moved into more like platform engineering stuff where we're building out full-on platforms for customers and automation and all that fun stuff. So I've touched like a lot of different aspects of Kubernetes over the years. So with that, let's go. So dynamic admission control in Kubernetes. So validating admission webhooks and mutating admission webhooks. If you've used Kubernetes for any length of time, you've probably used these at some point, whether you know it or not. They're used for a lot of different purposes, different use cases that kind of fit into one of these 4 buckets as I see it. The first one is around defaulting. So this is where your mutating webhooks come into play. These are things like automatically injecting image pull secrets into namespaces that get created, or injecting sidecars, which we see quite a lot. There's policy enforcement. So if your organization has certain policies that you need to adhere by within your cluster, so for example, not using the latest image tag, making sure that you're only ever using versioned ones, you can do that through a validating admission. Similarly, there's also like best practices. So either enforcing or encouraging your users to use things like pod disruption budgets, the right number of replicas, making sure your things are more resilient. And then my favorite one is problem mitigation. So who here remembers the log4shell exploit from a few years ago? It was a pretty big one, right? What was kind of cool is at Giant Swarm, we were able to instantly fix this for all of our customers by using a mutating webhook. So the way that the exploit worked, there's a certain code path that was exploitable, and you could turn off that code path by setting a specific environment variable. If you set this environment variable, I forget what it was off the top of my head, but if you set this environment variable, that code path was no longer run, so it was no longer exploitable. What we did is in all our clusters, we had a mutating webhook that on pod creation, regardless of what the pod is, set that environment variable on every container. Didn't matter if it had log4j or not. It had no side effects. It just then meant that every new pod created, safe. Very cool. We've had similar situations with other things as well where we've done this kind of thing. And webhooks are powerful things, but they do come with a certain amount of risk. Now, this isn't that talk. I'm not going to tell you today about all these risks that come with webhooks. I have given that talk before, so if you want to know about these headaches, either you can look at the talks I've given in the past or come find me later and I will tell you all about these headaches. But they can cause problems within your clusters if they go wrong. They can make a small issue, a small outage in your cluster into a big outage. So wouldn't it be great if we had a safer alternative? They didn't have some of these downsides. They're like, well, yes, it would. And it turns out we do now. I'd like to introduce you to ValidatingAdmissionPolicies. These were first introduced in Kubernetes in version 1.26 as an alpha. And as of 1.30, they are generally available and stable. So you can all use these as of today. And they are a declarative in-process alternative to validating admission webhooks. And by that, what I mean is declarative in that we define them as Kubernetes manifests. So these are CRDs. In process in that they run inside the API server itself. So you don't need to run an extra pod that runs this logic for you. As long as the API server is running, your policy is running too. So it's a lot safer. There is this thing called Common Expression Language, or CEL. I will talk a little bit more about this shortly if you haven't come across this before. And there are two main resources that you need to know about. So validating admission policy, which describes the policy logic, and then validating admission policy binding, which links it to the things that you want to apply it to. So very quickly, a brief introduction to CEL if you haven't come across it. The syntax itself is very similar to a lot of C-based languages. So the example we've got here, self.min replicas is less than or equal to self.replicas, and self.replicas is less than or equal to self.max replicas. So this is making sure that our replicas are within a min and max bounds. CEL is designed to be embedded into other languages and is a kind of a focus on what I call like one-liners. So you're not going to write huge functions of CEL. You're generally going to write one little snippet and have lots of those. There is a small number of functions built into the CEL language itself. So things like being able to split strings into arrays, doing has to see whether something exists within it. And you can extend those functions with custom ones. So in Kubernetes, there are several additional ones that they have added as well that you can make use of. CEL, you may have already come across it in some other cloud native technologies. So Kubernetes uses it for some of their policies as well, as does the Tecton Triggers project uses it for some of theirs. It also has this concept of cost that kind of helps the expression to be safe and not have like memory leaks and run infinitely and all those kind of things. So it's really good for embedding it within other applications. So let's have a look at an example. So I'm going to do an example based on one of the practices that I mentioned at the start. So we are going to prevent the use of the latest image tag on all of the containers within our cluster. We want to make sure that people only ever use versioned images because we don't want those nasty mutable ones that could creep in with security vulnerabilities or whatever. So we've got a validating admission policy here. We give it a name, as we do with any resource. This name will then be used by our binding. We give it the failure policy. So this is what happens if the policy has an error in it, not if the policy is not met. So if my CEL expression is incorrect for whatever reason, typo, whatever, this is what will happen. It will actually fail. You can also set this to ignore if you want to allow your developers to write bad CEL. We've then got our match constraints. This is what we're actually going to apply this policy against, what is valid to run against. We can have multiple resource rules here. Just be aware that ideally pick resources that have the same schema to their spec. Otherwise, your CEL expression is going to be horrifically verbose and it's going to be nasty. I've picked here deployments, daemon sets, and stateful sets because they all have a spec.template.spec property that then is the pod. So they're all got this common structure that we can use within our expression. And in this example, it's on creation and updates of these resources. Then for each of these, we're going to have validations. So we can have multiple of these validations, and they all have to pass for it to be successful, for the policy to be successful. And we're going to start off with having a message. Now, you don't have to provide a message, but I highly, highly, highly recommend you do, because if you don't, the error that the user gets is just that big, long CEL expression, and it is not user-friendly at all. So please do write an error message. And then we have our actual expressions. This is where CEL comes into play. Now, one thing that even still catches me out on this is the expression of what is allowed, not what you are blocking, not what you are disallowing. So this is, it has to be something that is not latest, right? It's not, we're not blocking latest, we're allowing things that aren't latest. So we start off with an object, which is provided to us by the Kubernetes implementation of CEL. So object will always refer to whatever the resource is that we've matched against. So in our example, it is going to be a deployment, a daemon set, or a stateful set of some kind. And we can then start doing things on it. So on this, we're going to look at the spec.template.spec.containers, and then we're using a built-in function called .all. This allows us to run a function against an array. In this case, it's the array of containers in our pod spec. And for each of those, we then get the variable container, which we can then do our check against. So we're going to do container.image, and then another built-in one ends with checking for latest and whether it actually contains the colon or not. If it doesn't, it's implicitly latest, so we want to exclude that as well. And then because we also want to do init containers, but they are an optional property on the spec, we have to first check if it has init containers defined, and if it does, then we can look into them. Otherwise, this will error out while it's trying to run. Similarly, we may also do this for ephemeral containers, cycle containers, whatever. Cool. So once we've got our policy, we can then actually bind it to some workloads within our cluster. So we've got our validating admission policy binding here. It references the policy name that we've just had it in our previous resource, the prevent latest image tag. And then we have an array of validation actions that we want to take if the policy isn't met. Now, the reason this is an array is because it's possible to specify warn and audit, but no other combinations of multiples. Deny here will, deny, block the request. You can't actually do it. Warn will just give an error, a warning message to the user, but it will still persist. And then audit will actually create an entry in the Kubernetes audit log. So if you want to warn but still have the audit log, you can do that, but it still will then allow the request to go through. Deny also does audit anyway. And if we want to just apply to everything that matches the policy resources, we can just have an empty match resources here. Or alternatively, we can use something like match label. So we can say that this policy only applies in namespaces that have the label environment prod. Now, obviously, we are not using namespaces for prod and dev separation. We are using different clusters, but for this example, it's fine. And then we're going to create a deployment. Here I'm using Nginx latest. And as you can see, when I apply it, I get a very nice friendly error message, not the horrible CEL expression to say, sorry, this is not allowed by our policy. You can't use the latest tag. You have to go use something else. Cool. So that was relatively basic. We're just checking the incoming schema and making sure it matches. Let's have a look at some more advanced features that you can do with validating admission policies. There are more context values that are provided to you. So we've already seen objects that gives us the incoming object of the request, but we've also got old object if it is an update or a delete. We've got namespace object, which gives us a reference to the namespace that the object is within, if it is a namespaced resource. And we also have request, which gives us some more information about the thing making the request. So for example, here, I implicitly trust the kubelet. I think the kubelet knows what it's doing. I'm not going to apply any policies to the kubelet. And I know that the kubelet belongs to the system nodes group. So I'm going to have an exclude here that checks the request.userinfo.groups to see if it's part of system nodes. And if we find out that it is that, this policy doesn't apply to that. So kubelet, do what you want. Parameters. So to be able to reuse your policies, you may want to make use of parameters. So the same policy can be used in, for example, different namespaces with different configurations. Here we've got a validating admission policy on the left that defines a param kind of this custom resource that I've made up called replica limit. And we then use that within our expression to say, we'll make sure that the object.spec.replicas is less than whatever this param.maxReplicas is, less than or equal, sorry. We then have to use our policy binding to attach a particular instance of the parameter to our policy. So this allows us to have different policy bindings that can use in different ways, but reusing the same policy. So here we're using a param.ref of my parameters in the default in the default namespace. And as you see on the far right, we've got a max replicas here of 3. So within the default namespace, we can't deploy anything with more than 3 replicas. If in my production namespace, that I said is a bad idea, but if we had that and we wanted to set this to 10, for example, or 15 or whatever, we could then reuse the same policy because it's cluster scoped, and then have different parameters. That means we can use the same policy in different scenarios. Great. Variables, not to be confused with parameters. Variables are reusable bits of CEL expression within your policy. So one thing to note with this is the variable name has to be a CEL valid identifier, not a Kubernetes valid identifier. So that means that camel case is okay, hyphens and stuff not okay. It called me out a couple of times. What this means is we can define a variable within our policy itself. So here I've defined this team label variable that equates to this CEL expression here. This CEL expression will check if there is a team label within the object.spec.metadata.labels. If there is, we're going to set it to the value of that label. If that label doesn't exist, we're going to default to no team. That means then in our expressions, rather than writing out that big long cell expression each time, we can just say variables.teamLabel equals to rel-eng. And often then we can have multiple of these, building up more complex cell expressions. Audit annotations. So I mentioned auditing very briefly earlier. You can add additional metadata to your audit log if a policy fails. You can set this audit annotations property, and you can have multiple of these. It's just like a key value pair. So you have a key, here is replica count, and then the value expression is a cell expression that can then equate to something. So in this example, we're actually doing a deployment, spectral replicas are set to, and then actually pulling out the value of what they tried to set it to. So in our audit log, we can then see it actually gets prepended, the key gets prepended with the policy name / the audit annotation key that we've set. And then you can see here, somebody tried to set it to 128 replicas when our max was 3. And finally, message expressions. So I already told you how important it is to set a message on your policies so that your users aren't scratching their heads. If you want that message to be a little bit more useful to the users, you can actually have dynamic messages using message expression, where again you can use CEL to have a dynamic string that gets returned back to them. So here I'm actually saying that object or spectral replicas can be no greater than, and then we're actually using that parameter from earlier, so it will be 3 in the example that we had earlier. Cool. So that's validation covered. What about mutating? Well, let me introduce you to mutating admission policies. Now, these are still alpha at the moment. They were introduced in Kubernetes 132, and I checked the release notes of 133 last night when I got back to the Airbnb that I was staying at, and they have not been promoted yet, unfortunately, so these are still alpha as far as I could see. They follow the same sort of policy, idea as the validating admission policies, and they introduced 2 new CRDs, mutating admission policy and mutating admission policy binding, just like same sort of thing. And they support 2 different patch strategies. So this is either apply configuration or a JSON patch. This is just kind of how it then does the mutation on the existing resource. As I said, this is not enabled by default because they are an alpha feature. If you want to enable them, you need to set the mutating admission policy feature gate, as well as enabling the admission registration API. If you want to test this out in a kind cluster, you can use this config that I've got down here with kind create cluster and then pass in that, and that will allow you to then try it out in kind with the mutation enabled, as well as the validating that is enabled by default now. So let's have a little look. In this example, I am going to inject some proxy environment variables into my pods. So in this scenario, we have a cluster that is private and everything has to go out via a proxy, a HTTP proxy. I don't want to have all of my Helm chart developers know what these values are and have to update them each time. So I'm just going to have the cluster do it for them on creation of these pods. So again, same as validating admission policies, we've got these same sort of fields. One thing we do have that's new is this reinvocation policy. Now, this is a similar idea as the mutating admission webhooks. If you do a mutation and then another mutation also happens to that same request, you can define here whether your policy should be reapplied on top of that other mutation. Because there's no guaranteed ordering of what the mutations are applied in. So if you do have multiple, you may end up competing with each other. Now, the reinvocation will only happen an additional 1 time. So a maximum of 2 times is your policy will be applied. That is it. Yeah. And then we've got mutations. So rather than validation, we've got mutations, and it's mostly the same but slightly different. So we've got this patch type. As I said, we've got apply configuration or JSON patch. In this example, I'm going to use apply configuration because it's kind of the easiest to explain. This is the same sort of strategy that's used when you do a kube control apply YAML file. So we define here our apply configuration. If my patch type was JSON patch, this would also be JSON patch. And then we've got an expression. Now, you may notice here that we've got an object, but this is not the same object that we saw earlier because it's got a capital O rather than a little o. This is a type in the cell. An object here, again, refers to whatever object we are working against. So in our example, it is pods. So object will be the type of a pod. You can then access these things through a similar sort of spec structure that we've seen up until now, so the dot notation sort of thing. What I do want to say is here we're mutating on top of spec.containers, and then again we're using a built-in function here, map, rather than all this time, to say we're mapping on top of all of those containers. And what we want to do is add in this new environment variable into the into the containers env property. So this will merge with whatever's already there, and we will inject this HTTP proxy with this made-up value. Let's just pretend this is a thing that runs within the cluster. So now all of the containers that get created, all of the pods get created, will have this environment variable automatically injected, and then nobody needs to know what the HTTP proxy details are. They just get added automatically. Now, in this example, we are missing init containers and ephemeral containers, just because I haven't got the space to fit it all on here. It will be tiny text otherwise. Similarly to validating mission policies, we have a binding. No surprises here. The only difference is the lack of validation actions, because all it can do is apply the mutation. There's no like warn or anything like that, so that doesn't exist. And it's got a lot of the same advanced features. So again, the context values that we saw, so the object, old object, things like that. Parameters, again, and variables. But what it doesn't have is audit annotations, because it doesn't make sense, because it just applies the annotation. It's not blocking anything. Sorry, it just applies the mutation. It's not blocking anything like a validation does. And it also doesn't have message expressions, because it doesn't return messages back to the user. It just does the mutation as part of the API call. Cool. We all good so far? Do we want to look into the crystal ball, look at the future a little bit? Cool. So these are all, at the moment, quite speculative and basically my wish list of what I want to see for the future in this area. But these are based on kind of what we already see within the webhook side of things, and what we see with some third-party tools like Kyverno and OPA and things like that. So one thing that's not currently possible is generative policies. So being able to create new resources based on API calls. I imagine this is going to come at some point once the mutation admission policies are more stable and have graduated to GA. As of right now, there is no way to create new things other than using a webhook for these requests. Resource lookup. So this is something that's used quite heavily if you're using things like Kyverno, or if you built your own custom thing. You may want to perform a certain bit of logic based on some other resource status, whatever, within your cluster. You may want to look up the details from a config map or the status of a particular resource, things like that. That's currently not possible with the admission policies. The only way to kind of do this is with the parameters, but then you need like have a hard-coded parameter. You have to bind it. It's not quite the same as this dynamic resource lookup. Policy exceptions. So this is something you will see in things like Kyverno. A lot of the times in kind of big enterprises, you want to have a really strict policy of like, don't allow all these nasty security vulnerability sort of things. But I actually trust this one application, and I need a way to exclude that one application because the team can't do anything else or whatever. So you need this way of having policy exceptions. So that's probably something that will come in the future once we've got a bit more tooling and stuff around the validation. Policy reports. So we've already got the audit log, which is okay. I don't know about you, but I don't particularly enjoy skimming through a massive audit log. So I imagine that there's going to be some third-party policy report tooling that will allow us to see these validation failures and stuff in a much nicer way, being able to aggregate them and kind of see at a cluster level what is failing, what our users are trying to do, and all this kind of thing. And then something that I know is already happening is more abstraction. So, for example, Kyverno, which is heavily based on webhooks up until now, have already started work on implementing validating admission policies into their tooling where possible. So rather than relying on a Kyverno pod to be running, where possible, it will be able to be run in the API server itself, which means that in scenarios where Kyverno goes down for whatever reason, your cluster doesn't grind to a halt because every webhook is failing. I am well under time. So to summarize, if you are using webhooks, if you are building webhooks within your cluster for validating or mutating purposes, please have a look at admission policies. If you can move to them I highly recommend it because it is a much safer, much more performant way of doing it. You are slightly limited in what you can achieve, as we've seen, but I think that is going to improve, especially with feedback from the people that build these policies. So if you do have any, please do. As I said, validating admission policies are available to use now as a version 130 they were introduced. 132 had the alpha release of the mutating admission policies, and as of 133 that just got released, still not enabled by default yet, so you will have to manually enable them. So maybe not using those in production just yet, but please try them out and see if they will fit your use cases. Feedback to the community if not. And I expect some more abstractions and this sort of thing and tooling around this to create an easier way of creating these policies and things like that. And if you do want some examples, I have started a repo where admittedly there's not much there at the moment, but you can look at some policies that I've started to put together for kind of the examples that I've shown so far. If you have any that you've built yourself, I would love some contributions as well. And with that, I'd like to say thank you. You can get the slides here, and I'd love any feedback.